if you do get lucky enough to, if that's what you want to teach and you get lucky enough to teach that age, those grades, it's going to be really trippy for you because you all have gone through the learning of numbers and math and so forth. There you go. Part of what I'm going to try to talk about as we go through these concepts is what it kind of looks like on the student side. And it's really hard for us to put us into the shoes. You can do it. What's happening out there? Sorry. Yes. Okay. It's really kind of trippy for us to put ourselves in the shoes of a little person, a little human, that has no idea what the number system is. Are you guys all aware that every symbol we use has been chosen throughout history? Yes? How many numeration systems are you guys aware of? Do you even know what our numeration system is called? 0, 1, 2, 3, and the symbols that we use for them. You know what it's called? And you're all like, the numbers do. Anybody? They're the Hindu Arabic numerals. So we didn't invent them. We stole them. Well, not stole them. We kind of were like, that looks good. We'll use that. So we adopted it. Yes? Are you guys all with me? So I'm not going to suddenly turn this class into an evolution of math symbols class. Yes? But I do want you aware of the choices that we made as a human species at some point. So the really cool thing about chapter 2, one of the most fun things in chapter 2 for me is we talk about the Mayan numeration system, the Babylonian numeration system, even the ancient Chinese numeration system. Has anybody ever been to Chipotle? Anybody? Yes? I'm not asking if you eat the food. I don't know how you feel about that. Have you been there? Have you ever seen the art on the walls? There's this one, this guy who's got puffy cheeks and you go, I don't know. If you watch it, those are actually kind of the formal symbols for Mayan numerals. Yes, so the Mayans have a very basic way to do numerals, but then they have these formal ones, and they're kind of related to their deities in their culture. So is that kind of trippy? And then we're also going to talk about like Egyptian numerals. So if you ever go to the Museum of Natural History or the museum, any of the museums down in Balboa Park, I've done this. You go in and you see the ancient Egyptian tablets, and you're like, wait a minute, that's the number 9. What the shit? So from a student perspective, that's really cool when you walk in there and you have this connection with this ancient tablet. Okay. So we go. Okay. So let's do this. Let me start with getting back into what we barely got into last time. This TV's kind of freaking out. Just a little bit. If I say to you, and I can't remember how much I said last time about this, if I say to you set notation, if I just say that, in all your mathematical experiences, can anyone tell me anything about what that might? Parentheses, okay. That would be more like interval notation, right? Remember the parentheses and the brackets? Maybe? The open circle and the closed circle and the shading? Yes, okay.
It could be different. Up to 3 or 4 sections with the parentheses.
Oh, are you talking about points?
No.
No.
Like you can multiply it. It could be, like you showed us last time.
Oh, okay, all right. We'll see if it comes up. What about squiggly brackets? What about this year? 1, 2, 3. Yes? So fundamentally, what is a set in mathematics? What is a set? What is that? What does that mean? I'm sorry. I always point to that monitor because this is one I can see. It's the same thing over there. What is that? What is it? What does that mean when I write that? You're like, I don't know, man. You're the math boy.
Like a pair or something? Like
Huh?
this, like a set of shoes, a pair, they belong
Okay,
together.
so the set that is the shoes in your house. So I would write squiggly brackets and then I would describe your shoes, yes? So it's a collection of things. What is this a collection of? Numbers, some numbers, the first three counting numbers, yes? Are you guys all with me? So set is a collection of items. They don't have to be mathematical items, but they inherently have a mathematical quality to them, yes? So look, if I can also do a set, and the way we're gonna do sets most of the time, well, not most of the time, a decent amount of the time will be like this. So here's the set of the first three counting numbers. What is this a set of? Symbols. I love it. Shapes, symbols, whatever. Whatever the hell came into my mind at the moment, my pen hit the paper. Is there any connection between those two sets? So I like this. Some of you guys are shaking your head no, and I agree with you, and some of you guys just said yes, and I agree with you. Do those sets share anything? Do they share anything? There's a square in one. Is there a square in the other one? No, there's a star. So do they share anything in that sense? Do they share a quality? Do they share a descriptor? What's that? What is it that they share? Same quantity. Yes. Now, here's what's trippy as hell. You guys have this foundation that you've built all your other math stuff on, and the foundation is, here's what we use numbers for. It is possible you will be teaching people, little humans, that don't know what that is. They don't know they don't even know what it means. So, do you guys know when you get a kid, if you got a little one, and they're not in school yet, and you're the parent, and you're like, let me teach you how. Have you guys ever seen the movie Parenthood, by the way? It's a little old, it's got Steve Martin and Rick Moranis. You seen it? Do you remember the girl and the parents were like just all about making her do all this educational stuff? And then the boy, I love him, he put the trash can on his head and just ran into the wall. So two different parenting styles. So you could get a kid to do the song. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You know, it's not like ABC, but it's still like a chant. Do you agree with me? You with me? If I forced you to, and I just went, Oomba, Joomba, da ba ba, boop, you guys can say it, correct? You wouldn't know what the hell they mean, yes? I don't even know. But you could chant it with me, correct? Just because a student can go 1, 2, 3, 4, 5, doesn't mean they have any connection to what they're saying. Can you guys say Ooba, Juba, Duba? Do it. Do you have any connection to what the hell? You can start to make up your own connection. You with me? But do we all agree that 1, 2, 3 has a verified, validated, agreed upon meaning? Okay, all right, let me stop for a minute. All right. I'm kind of jealous of some of you guys. If you teach certain grades, I've only ever taught college, and most of the time I'm teaching students something they've already seen. You with me? I appreciate the challenge to try to repackage it so it makes sense. So somebody comes to me and they're like, yeah, I factored before, it never made sense. I'm like, challenge accepted. Let me try to explain this so it makes sense. Are you with me? But my first goal was to be a high school teacher. Did I tell you guys that? I took all the courses except for the last course to get my certification. And I often think about, what if I got to teach, and I do in college, I do get to teach something people for the first time, but what if I got to teach like a foundational thing for the first time? That would be so neat. You with me? It would also be a little nerve-wracking because I could feel the pressure of that moment. I mean, that's a huge moment in a human's life. So you could have that responsibility, and I don't mean to make it sound like it's going to crush you, but you have to step up to that, right, as a teacher, and you have to really realize, I am completely shaping this person's future. Yes? I am introducing this person to centuries of freaking stuff that humans talked about and decided upon. And we just have to catch these little newbies up. Oh yeah, here's the stuff we decided. Why? I don't know, we just did. Okay. Yes, maybe? Whatever, Jeff? Okay, sorry, I go off on tangents. So, let me step back. So do you all agree there is a connection And we already said the connection was the amount, the quantity, right? Okay. So there's some kind, these are not, if I put this sign, would that be accurate? So hell no, we're not going to use that sign. So if I call this, let's say call this set A and call this set B, if I want to capture the relationship, I would say this. I'm getting a little ahead of myself, but you know, what else is new? That symbol in the middle, you guys maybe have seen that symbol before, and if I put it above an equal sign, it means approximately. But in this context, in the context of sets of things, it means equivalent to, which is not equal to. Equivalent just means exactly what that is. It's got the same number of things. So I want you to think for a moment. When this little person, can you imagine the little person has got a square, a star, and an 8? That's infinity to me, but it's an 8 laying down. Oh, guys, he's good. I'm sorry. I don't mean to call this poor guy out. Yeah, you got it. You gotta meet it. All right. You're good. You gotta meet it. You gotta meet it with these doors. I have no idea why. This is the room with the monitor we never use, and the doors that don't want to let you in. They can see the square, the triangle, and the 8 that's laying there that we see as infinity. Yes? And they would come over, they could do this. They know the chant. 1, 2, 3, 4, 5, 6, and then you go, yay, and they're like, the human likes when I do that. I'll do it more. Guess, hey, 1, 2, 3, 4. Oh, yay. So they could go 1, 2, 3, 4. Did they apply the counting method correctly? No. Or they could go 1, 2, 2, 2. I mean, that's very easy for them because they haven't connected what the numbers signify to us yet. So it's really easy for them to make a mistake. They don't realize what the goal is. So one of the first things you have to do with a student, a young human who's not really worked with this much, is to get them to do the chant. That's the first thing. Just like A, B, C, D, E, F, G, twinkle little star, blah, blah, blah. Okay. We get them to do the chant, but then the next thing is 1 goes to box, 2 goes to star, 3 goes to 8 laying down. Yes? You with me? And then they really start to realize, oh, I'm making this. This is what's called I'm doing this in a very interesting word. So like if I do 1 goes here, 2 goes here, 3 goes there, which relates to us, we would just go 1, 2, 3, okay. Because we've internalized all this stuff already. I don't need help with the set and the do this. But they're going to have to do that to really make that connection. What they've done is they made what's called a one-to-one correspondence. So, where's this 1 go again? In the way I did this? 1 went to square. And if I go backwards, where'd square come from? Square came from 1. So do you see what 1-to-1 means? The 1 goes to square and the square goes to 1. One thing to one thing, vice versa. If you fully get that, you're not going to make the mistake we did earlier, counting 1 twice or not counting enough. Let me stop for a minute. So let me tell you something about this class. Somebody could ask you, hey, when you're taking that Math 125 class, or that weird dude, what'd you do today? And you're going to say stuff like this. You're going to say, we talked about long division. We talked about 3 minus 5 today. And they're going to be like, college class, you talk about 3 minus 5. And the thing is, we're not going to just talk about 3 minus 5. We're going to talk about how the shit you teach that to a little human who has never seen any of this stuff before. Right? We're going to be talking about basic stuff at a very high level. Because you, as a teacher, have to be aware of all the thought processes that are going in. You're not going to teach the student about that, but you have to know it. So you know what to do when they make a mistake, how to get them to understand it. I guess, again, I'm not trying to make you feel overwhelmed. I'm trying to make you appreciate the possible wonderful responsibility you could have if you get the job you want. Yes? All right, so let me do this. I've been sort of riffing for a while and I do that. Let me try to get myself coming in. So now we've talked about this symbol. What did that symbol mean again? Equivalent, I love it. So A is equivalent, which doesn't mean equal, to B. One-to-one correspondence is when I take the counting numbers 1, 2, 3, and I correspond each of them to an item. And that's what enables us to count things. Okay. So let me formalize, I'm sorry, you guys are still copying something. Let me formalize some stuff we've talked about here so far. So let me give us something we're a little more used to. Okay. So you've seen set notation before, you've seen it in algebra, you've seen it and so forth. That's the kind of normal mathematical way to do set notation. Okay, we got another contestant. Would you say that, would you say that 5 is an element of A? Would you say that 4 is an element of A? Yeah, so this is a symbol I think I talked about last time. Do you guys remember what that symbol was for is an element of? So 4 is an element of A, but 5 is not an element of A. And again, I talked about it really quickly at the end of the last class, but it's kind of cool. We got a little thing. It's actually not the letter E, but it does look like the letter E, and therefore is an element of. Makes sense. And of course, it's really beautiful. If it's not that, you just put a line through it. That's great. Not too bad. So with any math class, and with any mathematical concept, there are symbols we created to identify an idea. You guys have to catch up with the symbols we chose. Blah, blah, blah. Oh, here's something that's a little less. Dog, cat, minotaur. Are A and B equivalent? Nope, why not? What would make them equivalent? If you could go in and change one thing, what would you do to make them equivalent? Nope, they don't have to both be animals. What did equivalent mean again? Both sets have.
Quantitative.
Say again.
Quantitative.
This is the quantity. Both sets have the same amount, right? So if you could change one thing, what would you change? Yes.
Add another animal.
Add another animal, or what could I do instead? Take away A, B, C, or 4, right? So they either end up with both 3 or both 4. Is everybody with me? Okay. So, guess how? Okay. You're never gonna believe it. A is not equivalent to B. That's amazing. Is dog an element of B? Yes, dog is an element of B, and so forth. Okay, that's not that major of an idea. It's very straightforward. It's just getting used to the term, the symbology, the symbols. Okay. I think I said something about this yesterday, but can you tell me, real quick, how big is the set? Okay, how big is the set of all odd numbers less than 10? Huh? 5. Yeah, what are they?
3.
1.
Or 1, 3, 5, 7.
Yeah, so you got 5. Okay. How big is the set? Okay, you guys with me? How big is the set of all circles that have corners? 0. Beautiful. So I'm pretty sure I showed you this symbol last time. So if I said, how big is the set of all circles with corners? First off, you would look at me the way some of you guys just look at me like this. Beautiful. And then you go, well, 0, man. Okay, there you go. What do we say when the set is empty? So I could either do this. There's the empty set. Or what symbol can I use for an empty set? Yes, 0 with a slash. So then how big is it would be 0. Do you guys see the difference? 0 with a slash is a set that is empty. How big is that set? It's got 0 elements. So I think I made the point last time that if you write a 0 with this line through it, you need to stop. Because that's going to communicate something different. In fact, to most math people, it will communicate something different. Okay. What does it take if I have two sets C and D, and I want this statement to be true? What would have to be true?
Those values would have to be the same. The ones that you plug in, they have to be the same.
It'd be a little more specific. I know what you mean, but
like C equals 2, and like D equals 2.
so if the set of C contains 2, D would have to contain 2. Exactly. So whatever elements are in C would also have to be in D, and vice versa. Let me make sure you understand. So let me take this away from you. Go away. If C was this, and D is this, is every element of C in D? No, stop. You answered according to what you thought I was going to ask. Is every element of C in D?
Yes.
Yes. Is every element of D in C? So then they're not equal to each other, correct? Okay, so I just want our definition to be all-encompassing. If two sets are equal, everything in one is in the other, and vice versa. That would guarantee they're equal to each other, right? What would you say, though, is the relationship? They're not equal. Which one's bigger? D. Can you find set C in D? Yes. So what symbol did you guys use to represent a number is less than another number? Yeah, the inequality. Looks like the letter L fell over. Yes? That's how no alligators are needed. Which one's the less than? It's an L that fell over. Yes? Or alligator. You guys know what I mean when I say alligator? It wants to eat the big one. Okay. So here's what's really nifty. When I'm talking about numbers, 4 is less than 5. That is ground shaking. When I'm talking about sets, it's kind of funky, the symbol we decided to use. C is a subset of D. Do you see the connection between those two symbols? This one is a softer version of this one. Do you see that? This is the plane I don't want to be in. Thanks for flying south. That bam! We're dead. We took that turn and wait. I want to be in this one. Yeah, so that's a softer. So they actually mean something very similar, but this is only used for sets, and this is only used for numbers, comparing numbers. Have you, anybody ever seen that little symbol before? A little seat symbol. Looks like a little seat that somebody's sat on. Poor little thing. What else besides less than could I use to make that statement true up above? I don't know, that's a little vague question. What does this symbol here mean?
Not equal to?
No. Not equal to would be this.
Less than or equal.
Less than or equal to. So is this statement true? For it to be true, 4 either has to be less than 5 or it has to be equal to 5. So is that statement true? So if I said you either have to be a camel or you have to be a human, did I just say something true? Yes, because you're a human as far as I don't know. You could be a camel and a human thing. That's good job, by the way, if you are. All right. Well, somebody has like, I'm not to take this guy. have a similar idea. So this statement is true. It's or, yes? In fact, we're going to talk about or later. Or is more inclusive, or more. Let me just talk about this right now because it's going to come up here very quickly. Then we have and, we have or. Has anybody ever filed for scholarship, financial aid? Have you ever looked at scholarships? All right, back in my day, I'm an old man. So back in my day, then we had a financial aid office. We would walk to it and say, hey, how's it going? And they have this book, literally about this big. And it was a book of all the available scholarships. So guess what? Every 3 weeks, the damn thing would be reprinted. And I'm like, there go all the treats. But we'd sit down, crack it open, and start looking at, you have to be a math major. Yes! You have to have at least this GPA. Barely. You have to be this percentage American Indian. Damn! Flip, right? So when I'm looking through a list of requirements, you have to be this and this and this. The number of people that match that is doing what? Shrinking. So and always makes things less, or always makes things more. So or increases the chances you get in, or increases the ways to match what it wants. So 4 less than or equal to 5, it could be less than or equal to. So is this statement true? Jeff, there you go. Yes, because it equals. Okay, beautiful. Okay, all right. Okay. Oh yeah. Okay. Blah 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 blah. I already did all that. Okay. Okay. So if I have coming back. Oh wait, sorry. Coming back to this. C and D, how do you think I can capture their relations? I already did one way, but I could also say this. Right? Because that one says either C is a subset of D or C equals D. Same way as less than equal to. If I can say this, if that statement is true about 2 sets, we call C a proper subset of D. So for example, officially, these 2 sets here are subsets of each other. Because I can find each one in the other one. Do you see what I mean? But at the same time, doesn't it kind of feel weird to call this a subset of this? Do you agree with me? So is this a proper subset of this? No. Because it would not be true. Would this statement here be true? No, because E equals F. Right? So a proper subset is one where they don't equal, but one is contained in the other. Okay. So if you ever see the phrase proper subset, that means that one is going to be smaller than the other one, but it has only some of the same elements. I know this is very exciting. So I appreciate everybody's remaining calm. Okay. So it's really just a matter of getting used to the symbols, understanding the idea behind them. So let me ask you this. Has anyone ever seen a picture like this before? Does anyone know what the name of that is? Yeah, Venn diagram. Sorry, that's weird. Oh, I see what it's doing. Okay, that freaked me out how the other paper suddenly appeared. Venn diagram. Do you guys remember what the hell it was used for, besides confusing students? Okay, all right, I like it. Like the relationship, various relationships. So if I said, oh God, all I can think is freaking politics. If I said, sure, Jeff, Democrats and firemen. Yes? What's true about this person right there?
They're both.
They're a Democrat and a fireman, right? What's true about this person right here? They're neither. They're not a fireman and they're not a Democrat. Does that mean they're a Republican? Do you guys know how many political parties there are in America?
It's like 5.
There are 53 that I know of. How many of them have presidential candidates that run? Sorry, this is a total side note. All of them. Just, do they all get on the ballot in every state? No. Has everybody ever heard of libertarians? Some of you guys might be libertarian. Do you guys remember, do you guys know there's an American Communist Party? What was the name of that one? Oh my God. Anyway, sorry. There's some really silly ones. All right. And I mean no offense if you're a member of something I call silly. All right. So if I said, let me call this guy Joe, and let me call this person Jill. If I said, what is D and F? Joe, yes? Because why is Joe in the set? Come back to me. Okay. Why is Joe in that set? Because Joe is in D and F. So what if there's Mark here and there's Sally over here? Right? Is it still Joe? Yes. Because in order to get into the and set, you have to be in both. You have to be in this one and that one. So you see how it's harder to be in the and set. So and always decreases the size of the answer because you have more requirements to meet. So what if I said this? What if I said D or F? What if I said Dorf? What would that represent? Who's in there? Mark, Joe, Sally. Who's the only person not in there? So she's not coming to the Dorf victim party. So this will be Mark, Joe, Sally. Write his name down, Jeff. Okay. You guys all with me so far? Nothing major? The symbol we use for and is this symbol, and the symbol we use for or is this symbol. So if I was a parent and you two are my kids and I'm like the living room's a mess, I might go, you or you, one of you. You see how I got a U here? So that U symbol, that's kind of like one way to remember. And you see how this symbol looks like the letter A and the bar fell out? A for and, yes? Has anybody ever seen these symbols before? I'm certain most of you have. Some of you guys are like, no, dude, you're the only weird person that's showing me this. Can you guys see how to remember which one's which? If you just remember, and almost always makes things less, or almost always makes things more. In fact, you got the beautiful or more thing going on, yes? That will help you determine if the answer you come up with at least makes sense. Okay. Oh, so let's do more about this Venn diagram here. Make a new one. How would I represent that shaded piece symbolically? What does that represent? That's all the elements that are where? Where are every element I just shaded? Where are they? Which circle are they in? A and B. So that's exactly what that region is called. That region is A and B. By the way, and is also sometimes called intersect. Isn't that where those two circles intersect? Okay. What about this? Sorry. My shading went a little crazy there. That shouldn't be. What am I trying to represent there? Yes, everything I shaded is in which circle? Circle A or circle B. So that's A or B. Kick ass. Beat the ball. By the way, see how I keep drawing the box? Sometimes you'll see Venn diagrams without the box and they actually don't make sense. That box represents my universe. Okay. So, what is, let me see if you guys get this, especially because I'm slamming it down here. What is this? Everything I shaded in, what is it? Try to answer it directly, but it's better to try to answer it by what it's not. What have I not shaded? A. So what's everything I shaded? Not A. Yes. You guys with me? So if I go back to this, if this was, if A was Democrats, I just shaded in everybody that's not a Democrat, yes? So this would be, all right, get ready. There. So if A's got a little weird freaking pipe hat on, that means not A. Has anyone ever taken like a probability class or like a statistics class? Yes? You guys, very often they use that as the complement of an event. Like if A is it's gonna rain, A with a bar would be it's not gonna rain. Yeah. Don't worry, it's not a prerequisite to this class. How are we doing so far? So again, today is a lot of just symbols for ideas. You gotta understand the idea. You gotta understand which symbol means it. Okay. Oh. How would you represent, using the squiggly bracket thing, how would you represent all of the counting numbers? How long would it take you to list them? How many are there? How many counting numbers are there? Huh?
9.
I like that. What's the next number after 9? So if I wanted to count to 100, could I? Yes. So every one of those numbers is a counting number. Could I go past 100? All right, so how many counting numbers are there? Good, infinite number. I love it. So is infinity, though, is it a number truly? Do you guys know what infinity is? Neat, what is it?
I don't remember.
I understand.
I remember it's like a white symbol. Like,
Yes.
It's like a number beyond. A number.
Yeah, so one way to kind of define it loosely is think of the biggest number you can, double it, then double that. But you see, anybody else have an idea what infinity might be? Never ending, kick ass. That's a really good way to look at it. So infinity is not a number, it's a process. The thing I just said to you, think of the largest number you can. Do you have it? Do you have it? No? I'm not going to play your game. I know what you're trying to do. If you think of the largest number you can, double it, right? Then take that one and double it. Then take that one and raise it to its own power. So would you all agree 18 trillion is pretty big? 18 trillion to the 18 trillionth power. Can you even understand what that means? Right, 18 trillion times, and then multiply it. Yes? Are you guys with me? Here's something really trippy, and I'm really sorry. I do tend to push things. That is no closer to infinity than 1 is. I might have gone too far just now. I'm really sorry. How far away from infinity is 1? It's just as far away as 2. It's just as far away as 2 short. Because infinity, again, infinity is a process. It never ends. So what's one way to define infinity? 1, 2, 3, 4, keep going. That's infinity. All right, I'll stop. I'm sorry. It's always like to get a feel for what you guys think of, because you've heard of infinity. Can you guys remember what in context you've heard of infinity? Besides freaking Toy Story or something.
It's used to like quantify love.
Ooh, yeah, you had the little infinity symbol. My love is never ending. Yes. Maybe you have a little picture of you on one side and a little picture on the other side. I'm sorry, and then of course, maybe you break up and you're like, well, infinity got here quick. I'm sorry, that's good. But yes, that's one way is like in expressing somebody's love for somebody else. Anything else? Any other, like a mathematical, or even not mathematical? Pi, okay, good. What is it about pi that has the idea of infinity?
You can keep trying to divide, but it'll keep going, you can still keep going.
Yeah, if you try, anybody know what pi is? Yes, it's Yomi, okay. Well, no, so it's, what is pi? 3.14, and is that pi? Now, you're beautiful, it's perfect, I love it, but is that pi? Why not?
There's more numbers.
There's more numbers, yes? 3.141596, and that is as many as I care to think. Yes. Some people win money for like remembering the 500,000th place of pi. You guys know this? Like, no. If I did that, I would forget my name. I'd have to make room. Yes. No, I'm fine. And real quick, March 14th is Pi Day. March 14th, 2015, because it's 3.1415. I was at a math conference and we had a little celebration, and I'm like, we are such geeks. We had little pies and we ate. Hey, pies, super pie day. Sorry. Yes, that's what math people do. I'll stop. Okay, so thank you. That's a beautiful example of infinity, because it actually is like counting. If they never end, that's a representation of infinity. Okay. So we have sets. So like the counting numbers. We have sets of things that never end. And of course we represent them with ellipses. Yes? I put an extra one there for some reason, I don't know. You guys have all heard of ellipses? Right, sounds like some ancient Greek person, nice cortex, I am ellipses. But it's just the dots at the end. Normally there's 3, minus 4. And very quick tangent. Do you guys know what the whole numbers are? There's the counting numbers. What are the whole numbers? There's only one difference between the counting numbers and the whole numbers. Say the word whole. What's it sound like? Whole. What's a whole look like? Yeah, so all the whole numbers do is it adds the idea of 0. Now very quickly. I'm sorry, yeah. Are you starting to understand what you have to deal with this semester? I'm sorry. There were entire civilizations that did not have a concept of 0. Babylonians, I always pick on them because they're very interesting. We're going to learn later, they didn't even have a symbol for 0 for most of their civilization. Then somebody invented a symbol for 0, and then their civilization ended. This guy's like, hey, God, yeah. Shit. So it's remarkably interesting. We have no idea what went into the stuff we take for granted. There were civilizations that did not have a concept of 0. Then there were civilizations that knew what 0 was, but they didn't make a symbol for it. Yes? You guys got it with me? A little bit? Okay. So the whole numbers is a totally different set to represent the evolution historically. If you just add the number 0, that's now called the whole numbers. Then you can add in, like my bank definitely did when I was a grad student. When I was a college student, my bank knew about the existence of negative numbers for damn sure. Right? My bank, you have negative money, so we're going to charge you. And I'm like, did you hear the first thing you said? I don't have any money. What do you mean you're going to charge me? So, anyone know what that's called when they add in the negatives? Anybody? Nobody? Huh? I like that, but no. It's one word, starts with an I. Integers. I like it. And then, of course, you add in fractions. Fractions. And that would be the rational numbers. Okay, I'll stop. Does that sound familiar, everybody? You guys remember that? Rational, because ratio. Fractions are ratios. I like it. Alright, let me see if I can push my luck. Do you guys know what 1/3 is as a decimal? Yeah, most of the time people know it's 0.3333 forever, yes? You guys kind of with me? Okay. Stay with me for a second. Do you guys know what 1/9 is? If you do it in your calculator, you can see, but don't do it. So let's do this. In algebra, when you don't know what something is, what did we call it? In algebra, if I don't know how much money I put in the bank, and you're like, what kind of weird, whatever. What would I call it to get the ball rolling? What do we call quantities we don't know in algebra? The main letter in algebra. What variables are in algebra? X. So if there's a quantity we don't know, one of the main letters we use for it is X. Is that cool? 1/9. Oh shit, you've gone and messed up, Jeff. I totally have. Forget I said it. 0.3333 is 1/3. What is 0.111 forever? Do you guys remember this symbol, by the way? Unfortunately, it looks like not A again, but that just means it keeps going forever. And I don't know what that is. Some of you guys can probably realize it's 1/9. If I don't know what that is as a fraction, I can just call it X. What sucks about this number? What's the immediate thing, besides it's a decimal, that sucks about it? It goes forever. Yes? Okay, so go with me. I'm sorry. I'm going to show you something kind of cool. It's actually going to come up later this semester, but I can't stop myself. What if I multiply both sides by 10? Do you guys remember what happens when you multiply a decimal by 10? Yeah, decimal moves. Why is that true? Because our system, our number system is based on 10, correct? We don't have any idea. We just don't know why it might be based on 10. If we had 8 fingers, it would be based on 8. And in chapter 2, we're going to talk about what that would look like. So that's something to look forward to, or not. So if I multiply both sides by 10, that's just going to move the decimal over once. So I get that. Is that cool? Now watch this. This is the coolest thing. And I don't know if you guys probably disagree with this. If I subtract both sides, what's 10x minus 1x? 9x, yes? And what happens when I subtract these two? What cancels? So what do I get? 1. And so if I divide by 9, x is 1/9. Anybody have a calculator? Do 1 divided by 9. What do you get? 0.1, and then it gives up because it's only got so much screen, right? It doesn't say open me more and then open me more and then open me more. So what do you think 2/9 is? If 1/9 is 0.11111, what's 2/9? 0.22222, what's 3/9? 0.333, what is 3 over 9 reduced to? Which we know from the beginning is freaking 0.33333 forever. You guys got it? Was that okay? Was that too much? A lot of what I just did are stuff related to stuff we're going to talk about later this semester, but you guys have done algebra, you've looked at decimals, you've done shit like this, and that's a really neat way to figure out how do I take this decimal and make it into a fraction. We're also going to talk about which decimals we can't make into a fraction, right? Later, okay. Jeff, man, going on so many tangents, I know. Leave me alone. So every set we've talked about before these two are examples of infinite sets. Every set we talked about before are remarkably enough finite sets. Kick ass. Sure, Jeff. Oh, this is perfect. I can finally shut up. You guys will be so excited. So, what I want you guys to do All right, guys. Let's talk about this. I have no idea what I'm talking about.
That's gonna be the same that, but not.
Okay. So one little tiny thing I kind of left out was, this is the universe. So I was telling one group of students, I said, what if I'm talking about animals? And one group is all the animals with hooves, and one group is all the animals without hooves. And then somebody says, all right, where do I put my Nissan first? Which group does that come in? You're like, it's not an animal. That can't be. So when I give you the universe, that's everything that could have been in A or B. You with me? So when I ask you a question like, what's not B? Now it's possible to answer. What is not in B that could have been in B? So then you compare B to the universe. Yes? I like, which is a phrase you didn't think you'd hear today. Compare B to the universe. Okay. So let's start over here. What does that symbol there mean? And, or intersect, right? Intersect sometimes is a great way to think about it, because where do the two sets intersect? Where do they agree? What is in both?
7.
Yes, 7 and 26. Do you understand, and this might be you, so you're like, yes, I understand this. Do you understand why a student might have put all the numbers from both?
Yeah.
And it's English's fault. Yes? If I said all of you and all of you come with me, every single person's come with me. That's how we use and in English. But we also use and like stand up if you're wearing shoes and glasses. You know, then everybody wearing glasses, well, hopefully you're all wearing shoes. That's a bad example. I think you guys do. So in math, when I say and, that is the restrictive and. You have to be in both. You have to match both requirements. Okay. So it's always going to be a smaller answer when it's an and question. So now number 2 is not that bad. What's not in B that could have been in B? Yeah, 0, 3, 4, 18. So you basically look at the universe and you say, well, which ones are in there, and whatever's left is what's not in there. That's not B. Yes, sir?
Will you mark off if we don't put them in like this anymore?
No. In fact, look at my set B. Do you see set B? Is that in order?
Gotcha.
So it doesn't need to be in order. We do sort of default to them being in order, but to be honest, the reason I did this out of order is to make it a little easier to see what's not similar, you know what I mean? So it does not have to be in order, no. Okay. Now, here's the trick. If you look at this and you try to do the answer looking up there, you're gonna go a little insane. But didn't you give yourself not B right there? So what is this saying? I want you to list everything that is in set A or set not B. Yes? So everything that's in A goes in there. You with me? So here's how the way I answer an or question. Take the first dude, put them all down there. They're all in there because they are in A, so they are in A or not B, correct? Now what am I going to add to that? Yeah, everything that's in not B that I haven't listed already, right? So I haven't listed 0. I haven't listed 3. So is everything I just wrote, every number I just wrote, is every number in here in A or in not B? Yes. 3 is in not B. 7 is in A. Yeah, blah, blah, blah. Okay. How you guys doing? Okay. This is the first one that I had not talked about with you at all, which seems really mean, but this is not a quiz, so I don't care. You know subtraction means take away from. So if I start with set A, because that's what I put A first. A, you have set A. Take away from it everything that's in B. What are you left with?
4, 18,
Oh, I see what you're doing. Okay. Start with set A. Start with set A. Take away everything from it that's in set B. So what am I going to take away from A? 7, 26. So that's the answer, 418. If I take stuff away from A, can my answer end up having stuff in it that was not in A? I don't know if this makes sense. you start with a set A, you take stuff away from it, can you end up with stuff in it that you didn't have in there in the first place? No. Does that make sense? That is the one difference between subtraction of numbers and subtraction of sets. You could do 2 minus 5, even though 5 is bigger than your 2, yes? It's got more stuff than your 2 in a way, but when I'm talking about sets, it's actually talking about taking elements away. So I just ignore the -4 and the -10, they're not gonna affect me, because it wasn't something I had in the first place. How are we doing? Okay. B is another one I didn't talk about, but I like that most of you guys picked up on the fact that that's our symbol for times. And we will be using X for times, because most of you guys are teaching younger students, you'll be using X for times. Why did we stop doing that? Because algebra came along, right? And then it's like very confusing if I use X for times and X for I don't know what the hell this is. So it's beautiful. How many things are in A? 4. How many things are in B? So I had a lot of groups were like, I think the answer is 16. Maybe, but yes, it is. But here's why. Okay, this is what's called. I don't know if you guys are ready for this. Do you guys know what the XY plane is called? Besides XY plane, do you know it has an official name? You guys remember the XY plane? It's named after Rene Descartes. It's called the Cartesian coordinate system. Has everybody ever heard of that? But if I just say XY plane, you know what I'm talking about. So to give props to the dude Descartes, Rene Descartes, we call it the Cartesian coordinate system if you're a weird math teacher. We call this a Cartesian product. Let me see if you guys are cool with this. If you take an element from A and you pair it with another element from B, how many pairs can you make? So for example, you don't have to do this work for this question, but let me show you what this really means. Can't I make the point, and this is why it's related to Descartes, because it comes, how do you represent a point on the XY plane? Isn't it a number, comma number? So can I can make 4, 7, is that cool? That's a pair I can make, yes? And I can make 4, 26, and I can make, dadgummit Jeff, I can make a mess. I can make 4, -4, I can make 4, -10. And I can make 7, 7, and I can make 7, 26. Do you see what I'm saying? How many pairs will I end up with? Well, how many options is there for the first number? 4. And how many options is there for the second number? And that's the definition of multiplication, 4 times 4. So this symbol actually means the Cartesian product between two sets, but then we just stole it for just multiplying two numbers. So how many elements are in set A? How many elements are in set B? So when I want to do a Cartesian product, I want to know how many things are going to end up. I just do the multiplication. If I say, what is A cross B? Shit, I got to write all these things now. You guys see how I'm nowhere near done? Okay, so I'm not going to give you one that's huge. That's crazy. So all that symbol means when I'm talking about sets is just take every element, pair it with an element, do that as many times as you can. Yes?
So were you saying how many sets there would be, or what the sets would be?
How many elements? So what I've just created is the beginning. So this is one element. This is the second element. There would eventually be 16
Okay,
elements.
because I just wrote 16.
You're beautiful. I'm showing more work than I asked you for. I'm showing you what A cross B would be, and all I asked for is how many elements would there be. Is 4 not, all right, well, I gave it away. How do I read this? Is 4 not an element of not B? Look at not B. Is 4 not in there? No, so is 4 not an element of not B? No. Where are my English people? People that love English. You're like, that's a triple negative. Thanks, Jeff. 4 is not an element of not B. Okay, moving on. What's the symbol in part D mean? We've talked about it a few times, you guys know. Equivalent. Are they equivalent?
Yes.
Because they have the same number of elements. Kick-ass, yes? They don't have to share a damn thing, but they have to have the same number of elements. Okay. Yep. Okay. What time is it? Damn it, Jeff. All right. On this problem, number 2, how many circles do I need? 2. Should they intersect?
Yes.
How do you know? They don't always intersect, correct? If I had lobsters and mint chocolate chip ice cream, would there be an intersection? If there were, there would be a lobster that is mint chocolate ice cream, and that freaks me the shit out because I don't like lobster, but I love mint chocolate. Sorry, it's in the water saying I'm dissolving. So I have a where am I at? A left-handed and an artistic. So where must 3 go? The trick is, I talked to one group about this, I think. The trick is start with the innermost. So where's 3 go? In the middle, because it's the one that's in both. Now, how many people did you just put into the left-handed circle? You just put 3 in there, correct? Aren't there 3 people in the left-handed circle? And how many total are supposed to be? So how many should I put right here? 2. Now there's 5 in the left hand. So the most common mistake is to put a 5 down. Now real quick, I kind of set you up for that mistake. And for that, I don't apologize. Because this is not a quiz, I don't care. But to me, if you make this kind of problem, it's really easy to forget that. So if I kind of let you make a mistake and then show you the right way, it'll stick in your head more. But wear that shirt, making mistakes the last thing you do. All right, sorry. So yeah, sometimes as a teacher, you want to be mean and let your students make mistakes. So of course, what's going to go right here? 16, so I end up with 19 total. So how do I figure out what goes out here? How many people are not, because how many people do I have so far? 5, 16, 21, yes? And how many total people did I have? So how many are here? 17. So can you answer the question then? Yes. How many? 17. How many mischief? Okay, and then very quickly, okay, let's see if I can give this enough time. I think everybody got 3A. So what regions are in A and in B? That's only what? 2 and 6. Which regions are in B or C? Well, then you just write everything that's in B, and then you add to it anything you haven't said yet that's in C. Your answer has to have everything that's in either one. What's that? Sorry? 5 and 4. Thank you. Does anyone think they got part C? Or did everybody kind of leave it blank and go, we're going to talk about this? Yes, you got it? What'd you?
I don't know. Is it the A, like, kind of A-ish shape, like upside down?
A and?
B.
And B. Oh, A and B would just be this, yes? So let's start here. This is perfect. Let's start there. What am I missing?
5.
I'm only missing a 5, correct? Somebody help me out. What is A and C? What's A and C? No, come on. What's A and C? Not or. What's in A and in C? 5, 6. Do you see how it has the 5 I need? Now, listen. This is not an easy question, okay? So if I do this and I do this, I just OR them. That's not the only answer, but I'm kind of stuck in it because that's the first thing I thought of. If I do A and B, that's 2 and 6, yes? And I do A and C, that is 5 and 6. And what is 2, 6, or 5, 6? 2, 5, 6. What's in 2, 6 or in 5, 6? 2, 5, 6. I love you guys. Remember, or is you take everything from both, yes? So what is in 2, 6 or 5, 6? 2, 5, 6. That's a great note to do this. So here's what's going to happen. We're going to take a quick little tour. It's going to be very quick. It's going to be at most like 10 minutes. And then you guys can leave, yes? So please don't leave yet. Can you gather, yes?
Super quick question. So if we move them, like say B intersecting A and then B
Oh, you're fine. Yeah, yeah, sort of like, yeah. If I say Joe and Jim and Joe, those
Yeah,
things.
and then do we have to have the parentheses on that?
Yes, that's another little trick thing. So guys, do me a favor, pack up. Listen, guys, listen. Start to walk that way, but very slowly. Let me get in front of you. It's gonna take me a minute here. Oh, it's gonna take me longer than that shit.